Hello, I'm David Stevenson, Product Manager for the Mako Core SDK at Hybrid Software Helix, formerly Global Graphics. In April 2025, we introduced a new rendering class for Mako Core that we named Apex, which runs on a GPU and is very fast, up to 10 times faster than the existing CPU-based JAWS renderer. Better performance is always a good thing. But it made us think that we should be improving performance in other areas of Mako. One of those is writing PDF, the inevitable result of converting from one of the many PDLs or page description languages that Mako supports, or simply taking a PDF as input, processing it in some way, color adjustment, imposition for example, then writing an output PDF. In this demo, I'm showcasing an early prototype of a new Mako feature, a multi-threaded PDF output class that will offer much faster PDF write times. To do this, I'm using the Apex multi-page demo. This presents empty boxes that represent pages waiting to be rendered. So that we have a basis for comparison, we'll begin the demo by rendering with JAWS and then write the output with Mako. Choosing the single-threaded output selects a standard Mako PDF output class, which is single-threaded. We'll also choose 600 DPI and we'll render 100 pages from this document. Each is a label of around 200 by 100 millimeters, 8 by 3 inches. I'll click Create Raster to get things going. And you'll notice the CPU, if you look over on the right hand side, there's a little meter there. The CPU is being fairly heavily used as each page is rendered on its own thread, which means actually they sometimes complete out of order. Now the rendering is complete, the PDF is being written. We are writing a Wrapped Raster PDF. This is essentially a pre-ripped version of a job. Each page is stored as a rendered image, so the heavy lifting normally is performed by the press side rip has already been done. This brings several practical advantages. Because the raster is final, it can be color corrected precisely for the intended press, inkset and substrate, ensuring predictable results on output. It can also be halftone or FM screened, eliminating the need for that when processing at press time. Despite being fully rasterized, it remains a standard PDF, so it can be opened, inspected and annotated in familiar applications like Adobe Acrobat without requiring specialized proofing tools. Let's zoom in on the content so we can confirm that we're actually looking at a raster rather than vector information. You can see the edges of those characters. The raster data is efficiently compressed using the PDF model, typically FLATE or ZIP, keeping file sizes manageable even at high resolutions. In short, a Wrapped Raster PDF packages a ready-to-print view of the job in a portable, press-agnostic format. Now let's see the new PDF writer in action. I'll uncheck single-threaded output, and I'll also push the compression level up to 7, which I happen to know will produce a file of a comparable size. And let's just kick it off again. Because the PDF is actually being written as each page completes, and that process is faster, the render actually takes less time than before. Moreover, the write is complete as soon as the rendering is finished. There's no long wait to finalize the PDF as we saw before. The first run took around 50 seconds in total. This one a mere 12.5 seconds. In particular, notice that the time to actually write the PDF is negligible. And the file size is actually smaller. It's about 20 megabytes smaller than the output we produced before. However, the big win comes from the combination of the Apex GPU rendering and fast PDF writing. Let's see what happens when we switch to the Apex renderer. And just for fun, we'll halftone screen the output too, all on the GPU. If you look at the activity indicators on the right, you'll see the GPU and the CPU are being utilized. to complete the task, which takes just a mere 4.5 seconds. And you know what? I can go even faster. This particular machine is equipped with 2 GPUs, and Apex can take advantage of both of those. So let's see what happens if we run it again. So remember, this took 4.5 seconds. This time the job is done less than 3 seconds. And as before, we can preview the results, and this time when we zoom in, you'll notice that the output is screened. So we can see the effect of the screening on the output. What we've been seeing is fast compression of rendered images added to a Wrapped Raster PDF that consists purely of ready-to-print images. The combination of incredibly quick GPU native rendering with Apex and fast PDF writing is a compelling one, with the potential to shorten print cycles with the reassurance of a guaranteed result.